హాయ్ స్టూడెంట్స్, నేను మీ రాజేష్ దుందుల. ఈరోజు మనం ఎన్రిచ్మెంట్ ఆఫ్ ఫోర్ అండ్ లో యాక్టివిటీ సిరీస్, ఎక్స్ట్రాక్షన్ ఆఫ్ లో యాక్టివిటీ సిరీస్ మెటల్ అండ్ ఎక్స్ట్రాక్షన్ ఆఫ్ మోడరేట్ యాక్టివ్ సిరీస్ ఆఫ్ మెటల్స్, ఎక్స్ట్రాక్షన్ ఆఫ్ హై రియాక్టివ్ సిరీస్ మెటల్స్ అండ్ ఎలక్ట్రాలిసిస్ ప్రాసెస్ అండ్ ఎలక్ట్రోలైటిక్ రిడక్షన్స్ గురించి నేర్చుకుందాం. The elements and compounds which occurs naturally in earth crust are called minerals. From these minerals, we extract metals profitably without economical loss. That type of minerals are called ores. These all ores consistent or contain impurities. These impurities are called gum. Like these impurities, sand, clay, that type of. Remove these impurities, we apply different physical or chemical process. First, we understand the extraction of metals in low reactive series. Okay, first take extract low reactive metals. Already you know that mercury, silver, copper, gold. First take mercury. Mercury available in sulfide formation. Mercury available in sulfide formation. Mercury burn at presence of oxygen. Mercury burn at presence of oxygen. This reaction is called roasting. Ores are burned at presence of oxygen. The reactions are called roasting reaction. So here 2HGO plus 2SO2 is formed. Now these mercury oxide, here sulfide convert to oxide. Now heat directly mercury is reduced. Okay, here mercury is reduced. Next, another take copper sulfide, burn at presence of oxygen. Copper oxide is formed. On these copper oxide, self reduction, that means auto reduction means same ore take copper sulfide, react together, 6Cu plus SO2 is formed. Here also copper reduces. Here directly mercury is reduced, but in second situation copper reduced, auto reduction process. Next, moderate reactive metals. Already you know the moderate reactive metals: zinc, ferrum, plumbum, copper. Already copper is completed. Now take zinc. Zinc available in sulfide or carbonate formation. Zinc, Zns plus 3O2 gives 2ZnO plus SO2. 2ZnO plus 2SO2. Okay, right. Next one, zinc carbonate. This reaction is called roasting reaction. Zinc carbonate, directly heat zinc oxide and carbon dioxide are formed. Here sulfide ore convert to oxide, here carbonate ore convert to oxide. This reaction is called calcination reaction. These two oxides, on these two oxides, pass carbon. The carbon reduce the zinc metal and carbon monoxide is formed. Okay, here three different methods we use: directly heat method, second one auto reduction, third one is the carbon reduction. Totally we obtain the metals. Okay, in first situation, low active series metal we extract from ores. In second situation, auto reduction process apply, also metals we can extract. Here carbon reduction process we use metals extract. Sometime also we use displacement reaction. Displacement reaction means highly reactive metals react with low reactive compounds, displace the metal. For example, take 3MnO2 plus 4Al gives 3Mn plus 2Al2O3. Okay, here Here manganese is displaced. Okay. Next, thermite process. In thermite process are also we use the aluminum. Aluminum pass low reactive compounds like iron oxide Fu2O3. Fu2O3 plus 2Al gives 2Fe plus Al2O3. This reaction is called thermite reaction. Here aluminum reduce the lower reactive iron. Okay, in this reaction we use the joint the railway tracks and cracked parts join the cracked machinery parts. Okay, in this reaction is very useful to our day-to-day life activity. This reaction is called thermite reaction. Okay, totally different methods we choose extract the metals. Okay, directly heat method, self reduction or auto reduction, carbon reduction, displacement method also we use. Next, extraction of the metal top of the activity series. Extraction of the metals top of the activity series. Top of the activity series metals already know that potassium, sodium, calcium, magnesium, aluminum. The type of metals, these all metals we cannot apply any reduction process. These all metals available oxide and chloride formation. So in these all metals we apply electrolysis process. In electrolysis process we use the rods, graphite rods, some electrodes are used. In these two electrodes, one electrode is anode, second electrode is cathode. Second electrode is cathode. We take the molten state chloride ore some. For example, NaCl in molten state. Take NaCl in the beaker. Take NaCl in the beaker. Okay, switch on the circuit. Switch on the circuit. NaCl decomposes into Na plus and Cl minus. These Na plus ions are stored on the cathode. These Na plus ions are stored on the cathode. At cathode we observe that Na gives Na plus E minus. Na plus E minus. At anode 2Cl minus gives Cl2 plus 2E minus. Cl2 plus 2E minus. Okay, this reaction occurred at anode, this reaction at cathode. Okay, this is the electrolysis process. In electrolysis process, directly we obtain the pure metal. Electrolytic refining. Electrolytic refining is best for to extract the metals purely like zinc, copper, silver, tin, nickel, gold. The type of metals we can extract. But in this situation, we use impure metal is anode, pure metal is cathode. In this situation, we use impure metal is anode, pure metal is cathode. Okay, and suitable solution is the electrolyte. For example, we will obtain copper metal, take the copper sulfate solution. In case we will obtain gold, suitable gold solution. Take the solution is a electrolyte. Okay, impure metal is anode, pure metal is cathode, and a suitable electrolyte is taken and pour few drops of acids. That's why here I write acidified copper sulfate. Okay, acidified copper sulfate. Acidified copper sulfate means here we add some few drops of acids. In this acid, flow of electric current fast. Okay, so that's why acidified copper sulfate we use. In this copper sulfate, copper pure copper rod is cathode. Okay, impurity consisting rod is the anode. Okay, suitable acidified copper sulfate is the electrolyte. Now switch on the circuit. Copper sulfate, copper sulfate divided into Cu plus 2 and SO4 minus 2 ions. Cu plus 2 and SO4 minus 2 ions. These Cu plus 2 ions are transferred to cathode. These SO4 minus 2 ions join to the these SO4 minus 2 ions are joined to the copper sulfate solution. Okay, and again this reaction continuously happening. Okay, totally in impurity consisting of rod, metallic rod, totally all Cu plus 2 ions are stored on the cathode rod. Okay, impurities are stored bottom of the anode. These impurities are called anode mud. These impurities are called anode mud. Okay, this is the electrolytic refining. Okay, this is the best process. We will get the pure metals. Okay, next one, corrosion. What is corrosion? Corrosion means oxide formation or carbonate formation or sulfide formation on the ores. For example, on iron ores, oxide formation, iron oxide formation, that is the rust. Okay, iron to get rust, that is the corrosion. That is the best example of the corrosion. And copper gets carbonates, the green colored carbonate coating form on the surface of the metal, that is the copper carbonate, green colored copper carbonate form. This one also corrosion, example of the corrosion. And silver form on the sulfide. So actually silver is the white color. Actually silver is the white color. Silver sulfide form, black colored coating form on the surface, that is the silver sulfide. This one also example of the corrosion. Okay, one activity about corrosion. Take 3 test tubes. Take 3 test tubes. Mark the labels A, B and C. Take 3 test tubes. Mark the labels A, B, C. Okay, this is the test tube A, this is test tube B, this is the test tube C. Okay, in all test tubes, cleaned iron nails. Place cleaned iron nails in all test tubes. Okay, place clean iron nails in all test tubes. Okay, now pour in test tube A some water. Pour some water in test tube A. Pour some water in test tube A and cork it. Next, in test tube B, pour boiled water. The iron nails are completely immersed in water. Pour boiled water. The iron nails are completely immersed in water. Okay, and pour few drops of oil on the surface of the water. This oil prevents the oxidation. This oil form layer on the surface of the water and prevent the oxidation. Next, in third test tube, pour calcium chloride, anhydrous calcium chloride. This anhydrous calcium chloride remove the wetness. And cork it. And observe these test tubes undisturbed for few days. After observe what happened. Okay, we observe that only test tube A iron nails get corrode. And in test tube A iron nails form rust, but test tube B and test tube C iron nails do not get rust. Why? Test tube A iron nails placed at presence of wet and air. Okay, but test tube B iron nails placed at presence of water, but test tube C iron nails placed at presence of air only. But in test tube A iron nails place both air and water, but B test tube only water, C test tube only air. Only test tube A iron nails get corrode. So in this activity we can generalize that metals are corrode at presence of oxygen and water. Okay, metals corrode అవ్వాలంటే ఆక్సిజన్ మరియు తేమ రెండు కూడా అవసరము. Okay, when metals are corrode at presence of oxygen and humid, write an activity అని అడగొచ్చు. యాక్టివిటీ ఏంటంటే ఏమేంటంటే టు షో దట్ metals are corrode at presence of oxygen and humid. Material required: 3 test tubes, some iron nails and 3 rubber cocks, and water, boiled water, few drops oil and calcium chloride powder, anhydrous calcium chloride powder. First take procedure amma. First take 3 test tubes, mark the labels A, B and C. In test tube A, in all test tube place 3 iron nails in all test tubes, cleaned iron nails place in all these 3 test tubes. Now in test tube A, pour some water in test tube A and cork the test tube. Next in test tube B, pour boiled distilled water and add few drops of oil. This oil prevent the corrosion and cork it. In test tube C, pour some anhydrous calcium chloride. This anhydrous calcium chloride remove the wetness, okay, and cork it. And observe these 3 test tubes few days. Okay, after few days we observe that in test tube A iron nails get rusted but B and C do not get rust. Why? In test tube A iron nails place at presence of oxygen and water, air and water, but in test tube B iron nails place at water, but test tube C iron nails place at presence of air only. So in this activity we can understand that iron or metals are corrode at presence of air and water. Prevention of corrosion. Prevention of corrosion, we use the oiling, greasing, painting. Next to oiling, greasing, painting, galvanizing. Next one, chrome plating, anodizing or making alloys. These all are the best methods to prevent the corrosion. Painting, oiling, greasing, galvanizing and chrome plating. Galvanizing, chrome plating, anodizing. Next one, making alloys. These all are the suitable process to prevent the corrosion. Next one, galvanization. What is galvanization? Iron metal to prevent the corrosion, to prevent the rust formation. Zinc layer form on the surface of the metal. Okay, that is the galvanizing process. Zinc plus iron. Zinc metal is used for galvanizing process. Next one, alloy formation. In alloy formation is the best method. Actually, iron is a soft metal. We can break easily iron metal, but we add carbon 0.05%. We add carbon 0.05% to iron. The iron is a strong material. That is the alloy formation. Next, stainless steel. Iron plus nickel plus chromium. Iron is mixed with nickel and chromium. Okay, stainless steel is formed. Next one, brass. Brass means copper and zinc. Copper and zinc are mixed together. Brass is formed. And copper and tin are mixed together. Bronze metal is formed. This alloy formation is best to prevent the corrosion. Metals are strong and do not get rust, but these bronze and brass are bad conductors. Okay, but next one, amalgams. One metal is mercury, another metal anyone. That alloy formation is the amalgam. Amalgam, for example, sodium is mixed with mercury. That is a sodium amalgam, NaHd. Next, lead and tin. Lead and tin have low melting point. these alloy formation used as a solder, low melting point amma. These lead and tin, mixture of lead and tin solder use the electrical wires. Okay, soldering of electrical wires, use the soldering of the electrical wires. And another information amma, in alloy formation is used two or metals or more metals or one metal, one non-metal, one non-metal and more metals are mixing together in alloy formation. Okay, next one, 24 karat gold. 24 karat gold is not suitable for making jewelry. Okay, 22 karat gold, pure gold, and 2 carats copper or silver is added. Okay, okay, thank you students. నా వీడియో నచ్చినట్లయితే లైక్ చేయండి, మీ మిత్రులకు షేర్ చేయండి, ఇంకా నా ఛానల్ సబ్స్క్రైబ్ చేయకపోతే సబ్స్క్రైబ్ చేసుకోండి. థ్యాంక్ యూ ఫ్రెండ్స్.